Okay, so the question is essentially saying you've got some kind of container. In that container, you're mixing 50 milliliters, 50.0 milliliters of a 0.500 molar solution of HCl, which is acid, with 50.0 milliliters of 0.500 mole per liter NaOH. And once you mix these two in this acid-base reaction, the temperature goes from initially 25 degrees Celsius to 28.2 degrees Celsius. And the question is, what is the essentially joules per mole, or maybe it might even ask in kilojoules per mole, I don't remember, of the acid. So for this particular reaction. So kilojoules is a unit of energy, right? We're looking for heat here. That's gonna be our Q. So let's figure out how much heat we had in this reaction, and then we can compare that to the number of moles of acid. One of the first things that I like to do, because it asks for moles of acid, is figure out how many moles of acid there were. To do that, we multiply liters times mole per liter. So I'm gonna put this milli, I'm gonna just move the decimal place over 3 times to put it into liters. So we had 0.0500 liters. I know in a liter there's 0.500 mole. So I'm taking 0.05 times 0.5, and that will give me an answer of 0.0250 mole of HCl. So now we know how many moles of HCl. Now we just have to find out the Q. Well, Q for all our pre-meds equals MCAT, MC delta T. There's a hint that the question gives us, and it tells us that the density of the solution is equal to 1.00 grams per milliliter. That means every milliliter weighs a gram. So we added 50 milliliters here and 50 milliliters here. So our mass here is gonna be for the mass of 100 milliliters. But the cool thing is that it's 1 gram per milliliter. So this is actually end up being 100 grams. It tells us that our C, we can assume is 4.18. It doesn't say 184, so be careful with that. It says 4.18, and that's joules per gram K. Finally, our delta T. Our delta T is always gonna be T final minus T initial. In other words, 28.2 minus 25.0. And that gives us 3.2 now. Because we're looking at a delta, we could have added 273 and subtracted 273 and gotten the same answer, but that's in the lectures I provide. So just make sure you're paying attention to that. That it could be degrees Celsius or Kelvin. And what this will give us is our Q. This will give us our kilojoules. So when you calculate it out, I think you get 1,337.6 joules. Grams cancel, Kelvin cancels, and you're left with joules. All right, that's cool, but it asks for joules per mole or kilojoules per mole. We can go ahead if you want to and put it into kilojoules. Again, I don't know if it asks for that or not, and I don't have the question with me, but to put it in, so let's go joules per mole, and then we'll turn it into kilojoules per mole just in case. So for joules per mole, we're gonna say that's 1,337.6 joules, divided by the total number of mole of the acid, because it specifically said moles of the acid, divided by 0.0250. And you end up with an answer of 53,504, I think. In other words, in kilojoules per mole, so that's in joules per mole. In kilojoules per mole, that you just move it over 3 times. 53.5 kilojoules per mole. You might want to go back and pay attention to the fact that that only had 2 sig figs. This only had 2 sig figs. That only had 2 sig figs. This should only have 2 sig figs. That should only have 2 sig figs, and you get 54 kilojoules per mole. Hope that helps.